In this video, let's talk on elements, symbols, and atomicity. The picture you see here represents a sample of periodic table of the elements. The names of elements come from many sources, as you can see here in this picture. You can jot this down in your notes. Then let's proceed with elements. Read all this. Then let's proceed with elements. So let's start with elements. What is an element? An element is a substance which cannot be split into simpler substances by any chemical means. It means no matter what, you can't break elements down into another substance, so it will remain the same. So elements can be divided into metals and non-metals. So examples of metals are aluminum, sodium, potassium, silver, etc. Now, if you check the periodic table shown, you will see all the elements there. Then you can have a copy of periodic table. You can search through Google, you can download anyone. Then you need to be familiar with the elements. So some are metals, some are non-metals. Part of the metal is what I've mentioned, like aluminum, sodium, potassium, etc. Now, examples of non-metals are sulfur, hydrogen, chlorine, oxygen, etc. So an element consists of simple particles called atoms. Now, let's say symbols. You can jot points. So now let's say symbols. Symbols. So symbols can be defined as a mean of representing elements using letters. We use capital letters to represent one letter. So for example, if we have hydrogen, so for hydrogen we use H. That is, symbol is a means of representing elements using letter. That means letter H, capital H, represent hydrogen. So now we also have oxygen. We use O, capital O for oxygen, etc. That means if the letters that we use to represent that element is 1, we use a capital letter. Now we use a capital letter and a small letter to represent 2 letters, meaning if the symbols that represent a certain element are 2 letters, we are going to use 1 capital letter and 1 small letter. For example, calcium. Calcium will be Ca. You can see we use 1 capital and 1 small letter. So if the letters are 2, use 1 capital and use 1 small letter. Now magnesium. Magnesium. We have capital M and small g. So that is magnesium, etc. So if you check the periodic table, you will see different symbols there. So as we proceed in our chemistry, you will learn all the symbols and all the elements. Now let's see atomicity. Atomicity. So, and before we see atomicity, just know that symbol is just a means of representing elements. So instead of writing hydrogen, I'll be writing H. Instead of writing aluminum, we'll be writing Al. So symbol is just to make our chemistry easier. in terms of writing the elements. So we'll be using the symbols instead of writing them in full. So now, atomicity. Now, what is an atomicity? So the atomicity of an element is the number of atoms present in one molecule of the element. An element can be monoatomic if it contains one atom in its molecule. For example, helium. We'll use He to represent helium. Neon, we use Ne. You see, as I'm writing two letters, one will be capital, the other will be small. Neon. Argon, that will be Ar, etc. So each of these has atomicity of 1. If I write He, it means the subscript is 1. But we don't usually write subscripts 1. That is why we'll just write He. And that means its atomicity is 1 because it contains one atom. Now neon, Ne, also contain one atom. Argon, Ar, also contain one atom. So etc. So any element with one atom, then its atomicity is 1. Also, an element can be diatomic if it contains 2 atoms in its molecule. Now we have 7 diatomic molecules. They are oxygen. So note them. You need to jot everything. So we have oxygen. It's a diatomic. Why? It has 2 atoms in its molecule. So that is, this is 2 atoms of oxygen. So the subscript here represents atoms. So if I write O like this is 1 atom. So why? Because the subscript will be 1, and we don't usually write subscript 1. But if I write subscript 2, then this is 2 atoms of oxygen. So we have oxygen, we have nitrogen, that will be N2. We have chlorine, that will be Cl. We have fluorine, that is F2. Cl2 is diatomic. We have hydrogen, that is H2. We have bromine, that is Br2. We have iodine, that is I2. If you see, you can see all these elements are 7. So now this is oxygen molecule, this is nitrogen molecule, this is chlorine molecule, this is fluorine molecule, this is hydrogen molecule, etc. So anytime we write any of these in a chemical reaction, they must carry that subscript 2 because they exist as diatomic. That means if I ask you how many diatomic elements do we have, you say we have 7 diatomic elements, and these are the 7 diatomic elements. We will see them later as we proceed. Now, an element can be triatomic if it contains 3 atoms in its molecule. Example of triatomic is ozone. Ozone is O3. As you can see, The number of atoms here is 3, so it is triatomic. Now we also have polyatomic. We have polyatomic. If the subscript is from 4 upward, so you can say it is polyatomic. For example, if you have P4, S8, so we can call all these polyatomic. All metals and some other elements, such as carbon, do not have a simple structure, but consist of a very large and indefinite number of atoms bonded together. Their atomicity cannot be determined, and it is usually considered as 1, so take note of that. Atomicity may vary in different allotropes of the same element, so we are going to learn allotropes later, so as we proceed. So let's continue with our atomicity. Now, how can we find atomicity of an element? So the atomicity we are talking about, how can we find it? Number one, we can say atomicity is equals to relative molecular mass. Relative molecular mass over relative atomic mass. Relative atomic mass. Now, relative, I can short it to be atomicity equals relative molecular mass, that is RMM, over relative atomic mass, that is RAM. Can short it. Also, relative molecular mass, that is RMM, is equals to 2 times vapor density. So in short, we can say relative molecular mass is equals to 2 times vapor density. Now, if relative molecular mass is 2 times vapor density, then we can replace it here. That means my atomicity can also be 2 times vapor density divided by relative atomic mass. So let's see example on this. Now, example 1. Determine the atomicity of each of the following elements. So let's see examples. Determine the atomicity of each of the following elements. So A, an element with relative molecular mass. So an element with relative molecular mass of 160 and relative atomic mass of 80. B, an element with relative molecular mass of 32, and relative atomic mass of 16. C. An element with relative vapor density of 62 and relative atomic mass of 31. Now let's see this. What is the atomicity of this element? So now it's easy, because in A we have relative molecular mass is 160, and we have relative atomic mass is 80. And what do we say is atomicity? We said atomicity is equals to relative molecular mass divided by relative atomic mass. That means atomicity here, relative molecular mass is 160 divided by relative atomic mass is 80. That means the atomicity here is 2, like that. So let's see the B parts. An element with relative molecular mass of 32. B. Relative molecular mass of 32 and relative atomic mass of 16. Now, what should be the atomicity here? The atomicity is relative molecular mass over relative atomic mass. So what is the relative molecular mass? Relative molecular mass is 32. And what is relative atomic mass? Relative atomic mass is 16. That means the atomicity of this element is 2. 32 divided by 16, 2. Also, C. Relative vapor density of 62 and relative atomic mass of 31. So now, for the C, atomicity is what? In terms of relative vapor density, that means we have relative molecular mass divided by relative atomic mass. But we know that relative molecular mass is 2 times relative vapor density divided by relative atomic mass. So we know our relative vapor density as 62. That means this is 2 times 62 divided by 31. So now 31 here 1, 31 here 2. 2 times 2, 4. So the atomicity in this case is 4. So that is how you can find atomicity of an element if you know the relative molecular mass and you also know the relative atomic mass, or if you know the relative vapor density and you also know the relative atomic mass. So that is how you can find it. So now let's proceed. Note that let me clear this. So note that the chemical formula H2 indicates one molecule of hydrogen and contains 2 hydrogen atoms. Also, the chemical formula O3 indicates one molecule of ozone and contains 3 oxygen atoms. Now, one molecule, if I have subscripts here, the subscript here is 1. So it's 1 molecule of hydrogen. So if I have 3 at the back of this ozone, that is O3, this will be 3 molecules of ozone. If I have 2H2, this will be 2 molecules of hydrogen. So now, when writing the chemical formula representing more than one molecule of an element, the numeral indicates the number of molecules is written first, followed by the chemical formula of the element. Example: 3H2 represents 3 molecules of hydrogen and it contains 6 hydrogen atoms. How? This is the same thing as 3 times 2. That will be 3 times 2, which is 6. So that will be 6 hydrogen atoms. So 7O3 represents 7 molecules of ozone and it contains 7 times 3. So that will be 7 times 3, which is 21 oxygen atoms. This 2Na represents 2 molecules of sodium and it contains 2 times, now see the subscript is 1, but we don't need to be writing 1, so it's like saying 2 times 1, which is 2 atoms of sodium. So a molecule, now take note, what is now a molecule? A molecule is a particle made up of 2 or more atoms that are chemically bonded together. The number of atomic nuclei making up a molecule is a determinate number. For example, HCl, that is hydrochloric acid, is a molecule made up of 1 hydrogen atom bonded to 1 chlorine atom. Now it is made of 2 atoms and is called a diatomic molecule. So one way to recognize molecules is whether they are homonucleus made of only one element, such as H2. These ones are homonuclei: H2, O2, O3, N2, P4, S8. They are homonuclei because they have one element. Or we can have heteronuclei, that is, it's made of more than one element, such as this HCl is heteronuclear because you have hydrogen and chlorine, more than one element. CH4 is also heteronuclear because it has more than one element. C6H12O6 sucrose is also homonuclear because it has more than one element. So now let's see further example on atomicity. So let's see further example. So now find the atomicity. Find the atomicity of the following molecules. Now HCl, you can see that is heteronuclear because it contains more than one element. B, Al2, SO4 3. We are still going to name all this chemical formula. Now this one is hydrochloric acid, this one is aluminum sulfate, Now C, calcium nitrate, that is CaNO3 2. D, sulfuric acid, H2SO4. So you will know how to name all this later. So for now, find the atomicity of the following molecules. So what is atomicity again? Atomicity represents the total number of atoms present in a molecule. Now, to calculate the atomicity here, so we will take all the sum of all numbers of atoms present in the molecule. For A now, we have HCl. Here, the hydrogen chloride has one chlorine and one hydrogen atom. So its atomicity is one hydrogen plus one chlorine. So its atomicity is 2, just like that. That means the atomicity of HCl is 2. The number of atoms present in a molecule of a compound, element, etc. So now, B, we have Al2SO4 3. Now, in this compound, what is the atomicity? It is also heteronuclear. So now, let's see. Aluminum contains 2 atoms. So that is 2 atoms of aluminum. Now, how can you take care of these 3? Anytime you have subscripts outside a bracket, now this is how it will look like. That 3 will multiply everything in the bracket. Now, what do you have as subscript for S here? Is 1. So now this is the same thing as Al2 S3, that is 3 times 1, that will be 3. Then O12, that is 3 times 4, that will give us 12. So anytime you have subscripts outside a bracket, it will multiply all the subscripts inside the bracket. Take note. Now this will becomes, I have 2 atoms of aluminum here. How? Because the subscript is what? 2. That is diatomic. So because the number of atoms is 2, so 2 atoms of aluminum plus 3 atoms of sulfur plus 12 atoms of oxygen. So total number of atoms here is 17. So that means the number of atoms present in aluminum sulfate is 17. So now C, we have calcium nitrate, CaNO3 2. Now this is the same thing as Ca plus, now the subscript for N is 1, so we can say 2 times 1, 2. So this will becomes N2 O again, 2 times 3, 6. The number outside the bracket will multiply all the subscripts inside. So like that. So now with this, we can calculate the total number of atoms. Let me join it together. So this will be CaN2O6. So as the 2 will affect everything here. So I use the plus. So you will know that the 2 will not affect Ca because the Ca is not part of this bracket. So the subscript will only affect everything in the bracket only. So O6. Now calcium, how many atoms? We have 1 because the subscript is 1. We don't usually write subscript 1. So 1 calcium plus how many nitrogen? We have 2. That is 2 atoms of nitrogen. How many oxygen? We have 6. This is 6 atoms of oxygen. So total number of atoms here is 9. So that means in calcium nitrate we have 9 atoms. Now D, let's say we have H2SO4. You will say this one there is no bracket here, so it's single. That means in this case we have 2 atoms of hydrogen plus 1 atom of sulfur, as the subscript will be 1 there. So 1 atom of sulfur plus 4 atoms of oxygen. So total number of atoms here is 7. That means the atomicity of ACl is 2. The atomicity of aluminum sulfate is 17. The atomicity of calcium nitrate is 9. The atomicity of sulfuric acid is 7. Like that. So we are through with that also. Now let's see more example. So another example. Write down the atomicity of the elements in each of the following formula. Now A, let's say we have He, B, S8, C, N2, D, F2, E, O2, F, Fe3. Now for the first one, A, He, what is the atomicity here? The number of atoms present here is 1 because the subscript is 1. That means the atomicity here is 1. Now B, S8. How many sulfur do you have here? We have 8. So its atomicity is 8. C, N2. What is the atomicity here? I have 2 atoms of nitrogen. So its atomicity is 2. D, I have O2. F2. D, F2. What is the atomicity here? I have 2 atoms of iron. So that will be 2 atomicity. E, I have O2. I have 2 atoms of oxygen, so its atomicity is 2. Then the last one, F, I have Fe3. So this is iron. So the atomicity here is 3 because I have 3 atoms of iron. So you can see the number of atoms present in a molecule of an element here is, for helium is 1, for sulfur is 8, for nitrogen is 2, iron 2, oxygen 2, and iron 3. So let's see another one. Write down the molecular formula of each of the following elements given the atomicity. Now let's say we have A. Write down the molecular formula of each of the following elements given the atomicity. A, xenon. We have atomicity equals to 1. B. Chlorine. Atomicity equals to, let me use A for atomicity. Atomicity equals to 2. C. Ozone. Atomicity equals to 3. D. Phosphorus. Atomicity equals to 4. So write down the molecular formula of each of these elements. So if you have the atomicity in front, so now for xenon, the atomicity is 1. So xenon is Xe. So I will put 1 as a subscript because the atomicity I have here is 1. So this is the chemical formula. But we don't write subscript 1, so I'll leave it as Xe. B. Chlorine. Chlorine is Cl. But here we say the atomicity is 2. That means the chemical formula is Cl2. 3. Ozone is O, but the atomicity is 3. So I'll write it here. So the chemical formula for ozone here is O3. D. Phosphorus. P. The atomicity is 4. So I'll put it here as atom. So the number of atoms here is 4. So phosphorus is P4 here. So that is atomicity. Now the next one we'll consider will be valency. So I'll do this in another video. Valency. So revise everything here, just like introduction to the elements and atomicity, and try and download the periodic table so you'll be familiar with the elements with their symbols. So our next topic is valency. So as we proceed, your knowledge of chemistry too will be increasing. Thank you.